So we are in Chapter 5, Statistical Software, on the discussion of the open source JAMOVI software. So we're going to go and explore the first data set to explore the features of JAMOVI. Now, let me show you what kind of data set we have. A company that decided to study the existing car industry. And then say they research, explore a number of variables. So if X1 happens to be the miles per gallon, X2 engine, X3 the horsepower, X4 as the weight of the car, then we got the acceleration, year, manufacturer, and then we've got the origin of the cars, X7. And then we got number of cylinders, and finally a filter, as they call it, selected for the certain reason of research or not. Selecting number of subjects, right? Let's say a number of subjects. Decide the outcome of each variable. Say the mile per gallon obviously is a continuous kind of a value. Same does the engine, horsepower, weight as well, the accelerations. But the year, we're going to consider it as a nominal. Why is it nominal? Because we decided to work on, for example, the past 7 years model. Now the origin here, we have country of origins that we got defined 3 of them, either American, European, or Japanese manufacturers. So could consider them nominal as well. Cylinders, well, here you have an option either to consider as an ordinal kind of data or nominal, as you wish, depends on the design of the research. And finally, you've got dichotomous kind of variable like the filter. So since we understand the kind of data set we have, we may consider the first pillar is ready to take off. I mean, the data preparation now. This happens from the research side. Now we're ready to go start to collect the data as the first pillar, as we said, and we prepare the data set in a certain format. Now you've got the options we discussed earlier, either directly start to use JAMOVI and enter the name of the variable, make some description on it, and then you write the value of the variable for the first subject, for the second, etc. Or you may want to use, for example, an existing database if you decided to save this on a structural database. Otherwise, the most popular one is to use a spreadsheet. So all these options are available for you. But personally, I would rather to choose to start saving my data or prepare entering the data into a spreadsheet where once I'm done, maybe I could do like some kind of making sure there are no missing values, because we discussed earlier that maybe JAMOVI, the only downside of dealing with missing values, still not completely a mature feature. We need to start from somewhere. Now, most of the materials on the field of analysis, usually they bring a data set and they start directly showing you how to execute different tests, etc., that you have already learned. But I find this is a huge mistake, because if you want to do this or to go down this road, maybe you will be really confused. There is no specific target. I mean, analysis, it isn't about the number of tools that you know or the kind of software you have, but it's about the plan. So you need a plan, and a plan encapsulate with research with something called research question. So I'd assume that, or the best way to do is to write down number of questions that you're concerned to answer. So from this data set, for example, I would assume number of questions. First of all, what is the most important maybe variable that it concerns me? The mile per gallons, and that's about the consumption. And then you have these number of variables, right? Like the engine. There is a relation that you can try to investigate. For example, we have number of years, but we decided to figure out over the years, the miles per gallon become much more efficient or less than efficient, or maybe just efficient. So maybe you could say, in other words, that mile per gallon become more efficient as years pass by. Well, this is an assumption and a hypothetical thing. So if I want to do the test against a hypothetical value, you could say, this is the right test I'm going to choose. Otherwise, maybe you want to investigate mile per gallon between these 3 different groups are different or not. So we're talking about analysis of variance. etc. So that's what I'm saying. You have to decide on the question you want to answer before you jump into the analysis part. I will leave this for you by brainstorming yourself and try to figure out a number of questions. And I'm going to bring the real data set into JAMOVI. I have actually the data in CSV. I want you to focus on the target. The target is to investigate miles per gallon and its relation to other variables and how they behave all together. So basically, this is the data set. Now, the first thing I want to do is to deal with the clearance of the data set, if you will. I mean, just check out data set features. I mean, it's obvious there are a number of missing values. As I have mentioned, these I can't really deal with them at once like it used to be, for example, in other statistical software. If it would have been for coding, I could have done this just by one line of a code. But in JAMOVI, seems unfortunately still these are treated as missing values, and they just been excluded once the analysis has been done. So I'm gonna assume the features as it is. Otherwise, if you like, we can calculate the average of the miles per gallon for all the subjects and just fill out these manually. This is an option if you like to do that. Otherwise, you may just leave it in. JAMOVI will take care by excluding the entire subject. So first of all, I want to open actually the data and check out every variable in its own. So the first one is miles per gallon. And as you can see, the description is written directly as the miles per gallon. And it's a continuous. That's what we were talking about in the design of our research. It could be in a decimal number. It could be in an integer number. So we'll leave it as it is. The second one is the engine size. And you can see it is the engine displacement per inches. This again is a continuous. The horsepower, same as well. The weight, the acceleration, all this still. Now, come to the year. Now, the year has been put here as an ordinal. Well, this is an option. See, it's investigated from year 70 all the way to year 82. So we get like 12 years. I'm not sure if you want to leave it as it is ordinal, since 70 is older than 71, of course. Or maybe you want to consider as a nominal. I told you that will be left for you. Depends on the way you want to construct the research and what you are trying to figure out. Now, the next thing you want to check out the origins. Obviously, they are nominal. And you get like 3 different groups. This cylinder, again, as I expected, is an ordinal 8 cylinders. The filter as dichotomous, whether the car would be selected or not. So this is the exploration on the data dictionary as we have discussed in Pillar 1. Okay, the next thing we want to do, let's start first of all univariate analysis. So what you want to do on the analysis part by coming to exploration, and we go to the descriptive part. Now, basically on the descriptive side here, we will be looking at continuous type of values. All right. So it is not harmful to bring them all just by shift and select. If you look at the table, you get the mile per gallon, you get the engine, the horsepower, etc. And then you might want to check the statistics. For example, you've got like the missing values in the mile per gallon, 8 different subjects, they were not recorded. Also, I can see the horsepower, 6 subjects were not calculated. For now, let's just neglect this missing value, although it's not the right practice. But anyway, look at the mean now. Then we look at the median. These are by default, by the way, mean, median, standard deviation, minimum, maximum. So what we're going to do, you have ability here to split these by a certain group. For example, say I want to see by the origin of the car. If I bring this one, what would you see here for the American cars? Mile per gallon was 20.1, the European 27, and Japanese were 30. So what can you tell from these 3 different? Japanese car seems to be more efficient. In terms of the engine size, you could see the American engine is heavier than the Japanese, is 103 and just 248. And if you got like the horsepower of the American cars, which is of course logical to be even larger, the weight of the car, you could see is quite lighter, the Japanese car, than the American car. And the acceleration it's quite faster to see on the Japanese rather than the American car. So these are just eventually way of reading and understanding from what we have learned about the mean and how to interpret also the median as well, which we know now the median is the point where the number of values on the right and the left are equal. So these are something we have learned how to interpret and we understand. So for now, I will just keep it without investigating by groups. I'm going to actually to the plot. So I'm going to bring the histogram. This is the histogram for each variable that we have in our list of variables here. So let's look at the mile per gallon and try to bring this density function. How normally seems the data be? It's fairly normal. I wouldn't consider too much not normal distribution. For the engine, perhaps a little bit less normal than the mile per gallon. For the horsepower as well, maybe the weight. The best you could see the almost perfectly normally distributed the acceleration. Maybe you want to look at the box plot. The box plot, as we have discussed earlier, it shows you outliers and the distribution, the interquartile, the value that we have seen earlier here, the IQR, how it's been calculated. So for example, the box plot for the mile per gallon, if you look, it's almost all right. We got one outlier here, but in general, you could see the mean and the median seems to be within the same range here. You look to the engine, for example, here you can see why it doesn't look like normally good or distributed, because the mode is in one side, the median also on this side, but the mean happened to be somewhere around here. So you could see the mean is larger. That's why the squee was on the right hand side in this direction. It's the acceleration. You could see the data set. Though we have a number of outliers, but either you eliminate them automatically, the subject number 17 and 18 and the other subjects as well. So this is a quick exploration on the kind of univariate analysis on a continuous number. So let's now go ahead and see how can we explore the years, the origins, the cylinder frequency for distributions. So what we have got here, we have got the n outcome chi-squared. Now we're going to choose first of all the origins. All right. So here we could see that 65% of the population of the sample that we have were American manufacturers, 18 were European, 19 were Japanese. Now, the test of chi-square is significant. That means there is a huge difference between these three groups, and it's quite obvious the reason why. That's why we reject the null hypothesis that they are equal, and we accept the alternative that they are not, which is quite obvious. So let's try to do one more. The cylinders, the number of cylinders. See how is the distribution of the sample number in terms of the cylinder. So we know we have those 3, 4, 5, 6, and 8 cylinders different. 4 of them were 3 cylinders, which is almost negligible. It is almost 406 subjects, right? So 4 of them, that's why the value was very small. But if you look here, 51% were with 4 cylinders. So seems the 4 cylinders was the most common cars to be under investigation, right? 107 were 8 cylinders, right? 26% of them. Then followed by the 6 cylinders, and maybe the 3 and 5, they were not so much popular. And of course, significant level of difference between the proportion for each one of them. So this is how you do the univariate analysis, either by graphing, if you like, using the continuous, depends on the kind.